Welcome to third grade Unit 2, Forces and Interaction. We're going to go ahead and talk through this unit together. So this unit has two big ideas. The first one is about balance and unbalanced forces. And so things that have a balanced force applied to them are either going to stay in motion or stay at rest. And unbalanced forces are going to cause a change in motion. So a great diagram to look at that is tug of war. If you are playing tug of war against another team and the forces are balanced, everyone's going to stay still and not move. But if the forces are unbalanced, like the picture at the bottom, the group that's pulling harder will pull the other side along. So there's a greater force, and that's going to cause a change in motion. So the two standards that are related to that are 3-PS2-1, where students will plan and conduct an investigation to provide evidence of the effect of balance and unbalanced forces on the motion of an object. And then PS2-2, make observations and measurements of an object's motion to provide evidence that a pattern can be used to predict motion. The other big idea is about non-contact forces. So this unit, we're really going to focus on the magnetic non-contact forces. So a non-contact force is a force that can be applied without any contact between the two objects. So a paper clip can be pulled across the table or moved through a table even with a magnet. So there's not a contact force, but a force is still being applied. Gravity is also a non-contact force, as well as static electricity. So the two standards that focus on these non-contact forces are ask questions to determine the cause and effect relationships of electric or magnetic interactions between two objects not in contact with each other, and then define a simple problem that can be solved by applying scientific ideas about magnets. And the second one is going to be your design challenge. That little asterisk indicates that it's an engineering standard, and that's where we're going to integrate that design loop. If you want to find more about these two topics, you can watch two background videos by Paul Anderson. The first one's called Forces in Motion, and the second one is called Types of Interaction, and those can both be found in the unit plan towards the end of the unit plan. Let's jump into stage one. The two big essential questions are how do balanced and unbalanced forces affect an object, and what are the properties of magnets, and how can they be used every day. So on the right-hand side are those enduring understandings, the things that we want students to walk away with at the end of the unit. So make sure that you're previewing those and reviewing those with your team prior to teaching the unit. There are several ways we're going to integrate ELA and math. There's quite a few picture books that are tied to several of the units we're using. Students also have an opportunity to read some nonfiction text, as well as answer questions and cite evidence throughout the unit. The math is highly integrated into this unit. Students are doing a lot of graphing as well as measuring. So this is a great opportunity to bring in real-world application of those measurement and graphing standards for students. When you look at assessment, there's several formative assessments that come out through the unit itself, and then there's a unit scoring rubric or a unit scoring guide that you can use to score your students or to help kind of see where your students are on track for the unit, as well as their big end of the unit performance task is the designing a solution to a problem. Also a great time at the end of the unit to do an ACT Aspire interim test if it falls within the window, or a classroom assessment as well. And then remember, you can always be practicing ACT Aspire questions through the exemplars and the sandbox. Quite a few materials have been provided for you for these kits, including different types of magnets, marbles, straws, Hot Wheels. The things you'll need in addition are things like ramps, so whiteboards, wood, cardboard, things you can use for ramps, things to measure, paper clips, string, yarn, and then a bunch of magnetic and non-magnetic items you can have around your classroom. So it doesn't matter if those are specific, as long as you have a variety of things that students can look at. When you look at the community resources, there are several places that you can check out additional resources within our local community. Our sample unit plan really focuses the first 2.5 weeks or so on forces in motion, and the last week and a half or so on magnets. So we're going to jump into some of these activities. The first big idea is that balanced and unbalanced forces. So a great thing to do is to play tug of war and model that in PE, make a connection there. Really looking at that balanced and unbalanced force idea. And then launching into some investigations. So this is an example from Sheep in a Jeep. For our materials, we modified it to just be a Hot Wheels car instead of a farm animal and a Jeep for just simplicity's sake, but you're still doing the same concept of rolling the car down the ramp and measuring different distances. Students can also graph the data that they have and really share that. They also want to look for patterns, and that's really important. When you look at trial 1, trial 2, trial 3, have students look at patterns. If we did trial 4, trial 5, could we begin to make a prediction as to how far it would go based on our evidence and our data? Then students are really going to be designing their own investigation with a group, and this is really important that they have the opportunity to design their own investigation. So in this, there's some sample questions that they could use as extensions from the sheep and the Jeep investigation, or they could do another type of investigation on forces. But it's really important that students have the opportunity to design and interact with their own investigation. In addition to that investigation, there's a few other investigations that you can do. One's from mystery science on building bridges, or a marble rolled down a ramp, or even pulling a tub across different surfaces. So just various ways to look at those activities. When you jump into the non-contact forces, things like static electricity, a balloon in your hair, a balloon on wool, picking up paper with the static electricity, things like that is really simple and easy experiments to try. There's also work with determining the properties of a magnet and how we can determine whether something is magnetic or not. There's a lot of opportunities to explore with magnets, so have fun with that. Let kids really play and explore with the ideas of magnets. And then to finish up the unit, students are designing a solution to a problem using magnets. So they can use the problem solver unit from Picture Perfect or the standalone magnet design challenge journal within the. Finally, to wrap up, it's a great time at the end of the unit to do an ACT interim or classroom assessment, as well as taking a look at some exemplars and having students explore in the sandbox. Hope you guys enjoy Unit 2.